Okay, can you guys see my screen? Yes, no.
Yes.
All right, thank you. On our last session, which is last week, Wednesday, we did it. Okay, we worked on the differentiation theorem, and we did the rules of differentiation up to, I think, the product rule. Yeah. And I gave you guys exercises to do based on those rules that we did, differentiation rules. Do we have any questions on those? Any struggle?
I would just like to ask when we'll get those answers for the exercises.
Pardon?
When will those answers be made available to us?
I can't even remember the questions. If one can give me the exercises or send it via email, then I can post it on the discussion forum. Yeah, I can post the workings there, and then you can compare your workings with those ones. Or you guys, we can start with them now before we start with today's session. It's depend on you. But today's session is it's very short because it's just one rule, then the high derivative, then optimization. Okay, I guess someone will send it to me via email. Okay, today we'll start with the quotient rule, which is also the rule, the differentiation rule. Okay, suppose you are given a function with the denominator and the numerator. Okay, first we had a rule on a function like this. F at x equals to ax to the power n, and we did a rule whereby we were given a function of this form. Pardon?
Pardon me, ma'am. I notice now we start with the code, and I think last week we finished on the chain rule. We didn't do product rule.
We didn't do product rule?
No, we didn't start with the product rule.
Oh, thank you. I thought we did a product rule. It's okay. I'll start from the product rule. And then, okay, it was first, we were given a function like this, and we said if we are given a function like this, and we are asked to differentiate that function, then we can use a power rule here. And then another function was a function of a function, which, okay, there we were given a function like this. I'll write f at x as in h of g at x, right? And we said if we are given a function like this, like an outer function and an inside function, and we are asked to differentiate a function like this, we said we will use the chain rule, right? And today we'll start from a product rule. Okay. Suppose you are given a function as a product of two functions. For example, you are given a function f, and function f consists of two functions, like u at x and times v at x, right? If you are given a function like this and you are asked to differentiate it, you need to use a product rule. Okay, if you have a function like this and applying a product rule, you will have your derivative, which is f prime at x, would be the derivative of the first function, which is u prime at x, times the second function itself, plus the derivative of the second function times the first function itself. So we'll have u at x times v at x prime. Okay, we have u at x and v at x. We can find u prime at x from u at x and v prime at x from v at x. Okay, u prime at x means it is the derivative of this function, which is u at x, and v prime at x, it's the derivative of v at x. Okay, you can write this step, which is the product rule, as in like this again. Du at x with respect to x, meaning we are differentiating u with respect to x, times v at x, plus u at x times dv at x with respect to x. This is the same thing. There is no need to write both of them. You can just write one. It's still correct. It depends on which one do you prefer. Still means the same thing. Okay, let's do one example here. Suppose we are given f at x, whereby f at x is equal to e to the power x times ln x, and we are asked to find f prime at x. Right, you see, f at x is a product of two functions. We have this function, which is e to the power x, and we have this function, which is ln x. We can say let's u at x equals e to the power x, and v at x equals ln x. If this is u and this is v, this means f at x is equal to u at x times v at x, right? And then from here, you can just apply your product rule, which says if f at x is ux times vx, then f prime at x would be u prime x times vx plus ux times v prime x, right? Okay, this means f prime at x would be u prime at x times v at x plus u at x times v prime at x. Okay, for product rule, it doesn't matter which function you choose to differentiate first. If you choose to differentiate this function first, then this means you'll have v prime at x times u at x plus u prime at x times v at x. It doesn't matter, the answer will always be the same. Okay, we have u at x and v at x, and we need u prime and v prime. Okay, we said u at x is equal to e to the power x, right? And we want to find u prime at x. Okay, we said if we are given a function e to the power x last time, the derivative of that function is this function itself, right? So this means the derivative of u at x would be e to the power x, because the derivative of this function itself. Okay, and we have v at x equals to ln x, and we want to find u prime at x, right? And we said the rule here, if we are given ln x and you asked to find the derivative of ln x, then the derivative of this function would be 1 over x, right? Okay, now we have u at x, u prime, v, and v prime. We can just take these and substitute them back here. Okay, and if we do that, this means our f prime at x would be, okay, we have u prime at x as e to the power x. Then this is multiplied with v at x, and v at x, we said v at x is ln x. So we have ln x plus u at x is e to the power x, and v prime is 1 over x. And this is your answer. You can simplify it further here. You can leave it like this. And okay, this means if you are given e to the power x times ln x, and you are asked to find the derivative of this function, then your answer should obtain this as your answer. E to the power x ln x plus e to the power x times 1 over x. Before we move on, do we have questions here? Yes, no? Okay, I will take the silence as no. Okay, let's do another example. F at x equals 30 x squared plus 10x into 3x plus 2. Okay, again here, you are asked to find f prime at x. Okay. You see again here, f at x is given as a product of two functions, which is this function y, and this is function 2. Okay. Here you see, okay, we can simplify this. You can multiply these two brackets and make it one function, which is a polynomial, and we can use a power rule. But suppose we are told to use a product rule here. Okay, if you multiply out if you multiply these two brackets and then you find a polynomial, you use a power rule, you'll get the same answer as in when you use a product rule, right? But to avoid making mistakes, it's better you just use a product rule, right? Okay, now suppose we are asked to use a product rule here. I'll let this function to be u at x and let this to be v at x. Okay, if this function is u at x, so this means u at x is equal to 30 x squared plus 10x. Okay, we need u prime at x from this function. You see, u at x is now a polynomial function, which means to get u prime at x, we need to apply the power rule, right? And if we apply the power rule here, we'll have 60x plus 10, right? Okay, and again, we have our v at x is 3x plus 2, and we are asked to find v prime at x, because for us to apply the product rule here, we need u prime v prime. Okay, and our if our v prime is 3x plus 2, if our v at x is 3x plus 2, this means to get v prime, we need to apply a power rule again. And if we apply a power rule here, you should get 3, because the derivative of the constant is 0. Okay, now we have our u prime v prime. And then we can now apply our product rule. F prime at x, which says f prime at x would be u prime at x times v at x plus u at x times v prime at x. So the next step is just to substitute back our u v prime. Okay, and if you substitute this, you will get 60x plus 10 times 30x squared. Oh, it's times 3 times 3x plus 2 plus 30x squared plus 10x times 3. Okay, because you're writing a multiple choice, if you see this as the option, you can choose this one. But it's not good to leave your answer like this. You need to simplify until you can't simplify further. So the next step here is to just simplify this this equation, this function, and yeah, that would be your final answer after that, after simplifying these two brackets and then collecting the like terms. Okay, again, do we have questions?
Yes, ma'am. I just want to ask if we need to simplify further, and it isn't specifically asked that we need to use the product rule, can we not multiply from the start the brackets out, I think that'll still make it easier not to make mistakes, because multiplying these out are going to be a bigger chance of making mistakes.
Yes, you can do that, but suppose here you had maybe 4 and here you had 3, like this bracket to the power 3 and this bracket to the power 4. You see, it won't be easy to simplify. Okay, let's say we are writing an exam because it's needs time. So it's better to use a product rule here. But if this was the case, yes, you can just simplify and then use a power rule. The reason I did this simplify is because sometimes you are given, sometimes you'd be given this a product rule, okay, this bracket into a higher power, higher order, as in your exponent won't be 1 or 2, because if it's 1 or 2, it's easy to simplify. Just simplify first and then apply the power rule. But if the order of your exponent is more than 3, then it won't be easy. So that's why I did this one like this.
Okay, thank you.
Any more questions? Okay, let's do another example. Last example. Okay, let's do this one again. We are given f at x as a product of 2 functions, which is e to the power 3x times 30x squared plus 10x. And we are asked to find f prime at x. Again, here, you can just simplify the bracket and then, okay, even if you simplify a bracket, you're still going to use a product rule because of these 2 terms. Right. So if you see, if you simplify this bracket, you'll use a product rule twice. But if you don't simplify this bracket, you'll use a product rule once. Because suppose we first simplify it, okay? I'm just going to simplify it first. And if I do that, I will have 30x squared e to the power 3x plus 10x e to the power 3x. Right? You see, if it's simplified, that means I'll use a product rule here. And again, I'll have to use a product rule here. Right? Because I have function 1, function 2, and function 3, function 3 and function 4. But here, I only have function 1 and function 2. So I can just let this to be u at x and let this to be v at x, right? And if I do that, that means we have u at x equals e to the power 3x, and we have v at x equals 30x squared plus 10x. Okay, and we need u prime and v prime. Okay, if we said if we have a function e to the power a constant times x, right? Then the derivative of that function would be a constant times the function itself, right? From our last session. So this means our u at x would be 3 e to the power 3x, right? And here in Vx, we would apply a power rule. Says which will give us 60x plus 10, right? That means our f prime at x would be u prime v plus u v prime, right? And if we substitute this, you will have e to the power 3x into 30x squared plus 10x plus okay, there's 3 here, plus e to the power 3x times 60x plus 10. Okay, then the next step is to simplify these two brackets. Just, okay, you'll just multiply out these two brackets and then you collect the like terms. And that would be your f prime at x. Do we have questions? Yes, no. Please work on this one. Okay. Please do work on this one. I will give you 4 minutes. Okay, 5 minutes. You are given your f at x as that function, and you are asked to find f prime at x. Are you guys winning? Yes, no?
We tried.
Okay, that's good. What did you get as your U prime? Anyone?
I found x to the power 1 over 2.
Yes. You said x to the power 1 over 2?
Yes, please.
Anyone with a different answer? You
It's
all get
sorry, it's
1
1 over
over,
1 over a 2 root x.
okay. Anyone with a different answer again? Okay. Okay. Remember, from the hints I gave you guys last time, I said if you are given a function like this, you need to first convert a square root. You need to convert this function into a power function. And if you convert this function, you'll have your u at x as x to the power a half, right? And then after converting it to a power function, then you can apply the power rule. And if you apply a power rule, you'll have, because if you have f at x as x to the power n, then the power rule will give you f prime at x as n x to the power n minus 1, right? If you compare these two, you notice that your n is equal to 1 over 2, right? So you just have to come here and substitute 1 over 2 where there is n. And if you do that, you'll have your u prime at x is 1 over 2 x to the power 1 over 2 minus 1, right? And 1 over 2 minus 1 will give you x to the power minus 1 over 2, right? And I said you need to make sure you always leave your answer with a positive exponent. Right now it's negative. So this means your u prime at x would be 1 over 2 x to the power a half. And we know that x to the power a half is square root of half. So this means our v prime is 1 over 2 root x, right? Okay, and our if our v prime is x to the power 10 plus 3 e to the power 5x plus 5x, this means here we'll apply a power rule plus a chain rule to obtain v prime at x. because we have these two functions. Here we'll apply power rule, and we have this function. Here we'll apply a chain rule. Okay. And if we apply these two rules, we'll have our v prime at x as 10x to the power 9 plus 15 e to the power 5x plus 5. Did we all obtain our v prime as like this? Same as this one. Yes, no.
Yes.
In your own time, please, let's try and work on this one. F at x equals 10 root x okay. Again, here you have to find f prime at x. Okay. Before we move on to the quotient rule, do we have any questions on the product rule? I guess not. Okay, now suppose you are given your function is okay as a function that consists of two functions which they are given as in the form of a quotient function. Okay, like a function with a numerator and a denominator, but whereby the numerator and the denominator, they are both functions. Okay, for example, if you are given f at x as u at x over v at x. Okay, was there someone talking?
Yes, I'm sorry. I was just asking, can you maybe go up a bit? A bit more. All right. That part where the 3e to the power 5x, it turns into 15e to the power 5x. I'm not sure you got that.
Yeah.
Yes.
Okay. 3e to the power 5x. Okay, v at x is 3e to the power 5x, right? You see here you have two terms, this one and this one, meaning you have two functions. You can let this to be v1 and let this to be v2, right?
All right.
If you name your functions like this, that means your v prime at x would be v prime 1 times v2 plus v1 times v prime 2, right? Okay, we have v1 is 3. Remember, the derivative of the constant is 0, right? And you have v2 as e to the power 5x. And we said if we are given a function like this, e to the power a constant x, then the derivative of that function would be a constant times the function itself, right?
Yes.
Okay, we have all these three, we just have to substitute them back. We have v prime as 0 times v2 which is e to the power 5x, plus we have v1 as 3 times v prime 2, and v prime 2 is 5 times e to the power 5x, right?
Yes.
This gives you 0, plus you have 3 times 5. 3 times 5 is 15, e to the power 5x. Is it fine?
Yes, I get it. Thank you so much.
You sure?
Yes, thank you.
All right, thanks. Okay, I said suppose you are given a function like this in a form of a quotient function, as in they are given a function with the numerator and the denominator, whereby your numerator, both your numerator and the denominator are the functions, right? Okay. If you are given a function like this and you are asked to differentiate it, to find the derivative of it, then you will have to apply the quotient rule. Applying the quotient rule here, you will have f prime at x equals u prime at x times v at x minus u at x times v prime at x over u at x all squared. Okay, remember, for I want to go back to the product rule. Remember, for a product rule, right? I said if you are given a product of two functions and you are asked to differentiate them, you can differentiate this first and then multiply this, plus then you differentiate this, multiply by this, or you can differentiate this function first and then you multiply with this, then you differentiate this function second and you multiply with this one. This doesn't matter, the order doesn't matter. Okay, here on the quotient rule, you always have to differentiate the numerator first. Because of this negative. If you differentiate this first and then you differentiate this second, then your answer would be wrong. You always have to differentiate the numerator, then you multiply with the denominator, and then you differentiate then you subtract, you differentiate the denominator, you multiply with the numerator. Then everything over the numerator squared. Okay, here this part is not a derivative. We don't differentiate this part. You just have to square it. Right. Let's do an example here. Maybe. Okay, suppose we are given f at x as e to the power x over 2x plus 1. and we are asked to find f prime at x. Right. Okay, you see from this function, you can apply a product rule, right? Because you can write this function as e to the power x times 2x plus 1, everything to the power minus 1, right? And then from here, you can apply a product rule. But that would delay us, because the product rule would be the derivative of this function, the derivative of this function times this, plus the derivative of this function times this. But you see, when you want to find the derivative of this function, you need to apply the chain rule, right? So this means if you choose to apply the product rule here, if you simplify this function and make it in this form, and then apply the product rule, that means you'll have to apply another rule, which is the chain rule, and that will delay you. So it's better you just apply the quotient rule on this function without simplifying it. Okay. Let's apply the chain rule. We said if we are given f at x as in the form of the numerator and the denominator, well, let's okay, I'll say let's u at x to be ex and v at x to be 2x plus 1. We now have our u and v. If we are given our f at x as in the form of u and v, for us to apply the quotient rule, we'll need, we first have to find u prime and v prime from our u and v. Okay, we said our u is e to the power x. If u is e to the power x, that means your u prime at x will also be e to the power x, because the derivative of this function, it's this function itself. But our v prime at x, we need to apply the power rule here to get v prime. And if we apply the power rule, we'll have our v prime as 2. Right? Now we have our u prime, v prime. The next step is to substitute them back here. And that will give us our f prime, which is our derivative of that given function, right? If we substitute them back, you will have something like this. Okay. We have u prime times v minus u prime times minus u times v prime, which is 2 e to the power x over u or over v squared, which means over 2x plus 1 to the all squared. And this would be your derivative if you were given your function, like this, as in this form. Okay, but the next step here is to simplify. But because you're writing a multiple choice, you see this as your function, there's no need to simplify further. You just go and choose this one. But if this is not there, you have to simplify it further and try to make it write it in this simplest form. Do we have questions? Can we do another example? Yes, no questions. Okay. Suppose your f at x is equal to 1 plus e to the power x over ln x times two x. Yeah, I would leave it like this, times 2x. Right. We have f at x is equal to 1 plus e to the power x over ln x times 2x, and we are asked to find f prime at x, right? You see, f prime at x is given in the form of three functions, right? First, we can let our u to be 1 plus e to the power x, and we let our v to be ln x plus, ln x to x. Okay, I'll write this as 2x ln x. Please unmute your mic. Okay. If we let our u to be that and our v to be this means we have u over v, right? That means we need to find our u prime and our v prime, right? Okay, if u is this means our u prime would be e to the power x, right? Because the derivative of the constant is 0, meaning the derivative of 1 would be 0. And we have e to the power x. The derivative of e to the power x is e to the power x itself, right? But here, you see, our v is the product of two functions. I'll let function 1 u1 to be 2x and let v2 to be ln x, right? Meaning the derivative of v would be v1 prime times v2 plus sorry. Okay. To be plus v1 times v2 prime, right? If u1 is 2x, that means if v1 is 2x, that means your v1 prime would be 2, right? So we have 2 times. If okay, times v2. So it means we have 2 ln x, right? And we have our v1 is 2x. So we have 2x times if our v2 is ln x, that means our v2 prime would be 1 over x, right? And we can simplify this, and if we do that, you'll have this x and x will cancel out. You will have our v prime as 2 ln x plus 2. You can again write this as 2 into 1 plus ln x, but I'm just going to leave it like this for now. It's fine. Okay. Going back to our original equation, we said to find the for us to find the derivative of f at x, we need to apply the quotient rule. But for us to apply the quotient rule, we need u prime and v prime. Okay, now we have u prime and we have v prime, right? This means our f would be, okay, we have f at x equals, okay, f prime at x equals u prime v plus, okay, it's minus u v prime over v squared, right? Our u prime is e to the power x, and our v is 2x ln x, 2x ln x, minus our v is e to the power x, and our v prime is that, which is 2 ln x plus 2 over v squared, and v squared would be 2x ln x all squared, and this would be your f prime at x if you were given your f prime as in if you are given this function as your f at x, then that should be your f prime x. Do we have questions here? Yes, no? Okay, I guess not. Please, let's try and work on this one. F at x is one plus e to the power 2x over x squared. Okay. You'll find f prime at x. Okay, it's okay. Please work on this in your spare time. You have 1, you have 2, f at x equals 3x cubed plus 2x squared over x squared plus 2x plus 1. Again, here you find f prime at x. Do we have questions before we move on? Yes, no?
When will you share these answers, ma'am?
These answers.
Yes.
I will share them before we start the class. That's our next session, our last session on Wednesday. Yeah, on our last section on Wednesday. Okay, please do remind me these 2x questions, because by then I'll have forgotten about them. Okay, can we move on? Can I scroll down? Are you guys going to take these questions now or later when you study? When is assignment 2 due? Anyone?
I think it's on the 31st, ma'am.
Oh, okay. It covers just this. I don't remember. Okay. Let's move on to the higher order of derivatives. Okay, higher order derivatives. This is just the process of taking the derivative of a derivative. Okay, like sometimes our function, like the first derivative, can capture some information about most functions. If that's the case, then higher order derivative would be used to model or to represent your fund, like any model, right? And yeah, that's the reason why we need to learn higher order derivatives. And beside that, we use higher order derivative to determine the maximum and the minimum and the point of inflection, right? Like we'll use higher order derivative to determine the maximum profit, maximum revenue, or the minimum profit. Yeah, and the points where those where the maximum is obtained. Right, that's the reason why we need to learn, we need to study higher order derivatives. Okay, as I said, higher order derivative is just the process of taking the derivative of the derivatives. Like higher order derivative starts from second derivative, third derivative, fourth derivative, up to nth order derivative, whereby n is any integer. Okay. Second order derivative. That's that day. We said the first order derivative. Okay, suppose we are given a function f at x, right? And we said if you are asked to find the derivative of this f at x, then you'll denote that derivative as f prime at x, right? Or df over dx, right? This is just the first derivative. Now, suppose you are asked to find the second derivative or second order derivative, okay? Remember, we said high order is just the process of taking the derivative of the derivative, right? Meaning, if we want to find the second order derivative, we need to differentiate the first order derivative. Okay, you see the first order, I have 1 prime, right? And then for a second order, I have 2 prime. For a third order, again 3. Fourth order, again 4. Fifth order, right? The second order derivative will be the derivative of the first order. Okay, meaning we can write f prime prime at x as d over dx of f prime at x, right? Or you can write this as d over dx of, remember this is the first derivative, right? So we have d over dx of df of dx. This still means the second order derivative. Then the notation for a third order, remember I said for a third order we have 3 primes, right? You can, this is the notation for the third order, or again, you can write the third order as the derivative of the second derivative, meaning this is equal to d of dx of f prime prime at x. Or you can write this as d of dx of d squared f of dx squared, right? This 2 means f has been differentiated twice, right? Okay, this is the same as d3, which is d cubed of f over dx cubed. Again, this 3 means this f has been differentiated 3 times, right? Okay, this goes on until the nth order derivative. Okay, if the third order derivative, that derivative is the derivative of the second derivative, and the second derivative is the derivative of the first derivative. This means the nth order derivative is the derivative of f to the power n minus 1 at x, right? And n can be any number greater than 1. Okay, because we said the higher order derivative starts from 2 until n. It can be 2, 3, 4, etc. Okay, let's do an example here. Suppose you are given your C at x as x to the power 5 over 5, right? And you are asked to find first derivative of c, second derivative up to the third derivative. Again, here we're still going to use those rules of differentiation. They're still the same. The power rule for a first order, it's the same as the power rule for the second order and the power rule for a third order. Doesn't matter. The power rule is always the same. This doesn't matter which order we are asked to find, the order of the derivative we are asked to find. Again, the chain rule, the quotient rule, the product rule, they are all the same. The only thing that is different is just the number, the order of derivative, like how many times you are asked to differentiate that function. Okay. Again, suppose we are given this function. This function is 1 over 5 x to the power 5. This is c at x, right? We are asked to find the first derivative, the second derivative, and the third derivative. If this is the case, this means first, which is c prime at x, would be dc at x with respect to x, right? You see, our c at x is 1 over 5 x to the power 5. Here it's simple, we need to apply the power rule, right? And if we apply the power rule here, we will have, okay, we have 1 over 5 times 5 x to the power 5 minus 1, right? And this gives us, if we simplify further, 5 and 5 will cancel out and we'll have x to the power 4, because this is 5 minus 4. And this is our first derivative, which is c prime. Remember, we're asked to find the second derivative and the third derivative, right? Okay, we said the second derivative, it's the derivative of the first derivative, right? So it means if we want to find c prime, we need to differentiate. If we want to find c prime prime, we need to differentiate c prime. And c prime is x to the power 4, right? Again, to differentiate x to the power 4, we need to apply a power rule here, right? And if we apply a power rule, we'll have 4x to the power 3, right? Because you multiply with your power and then you subtract 1 from the power. And this is your second derivative, okay? We were asked to find the third derivative. Again, we said the third derivative is the derivative of the second derivative, right? Meaning c prime prime would be the derivative of 4x to the power 3, right? Again, here we'll have to apply a power rule, right? To get the third derivative, we apply the power rule on 4x cubed. And if you apply a power rule here, you'll have 4 times 3 x to the power 3 minus 1. And if you simplify this, you will have 12x squared, right? And let's say you were asked to find we asked to find the fourth order, differentiate 4 times, meaning we need to differentiate the third derivative. Okay, we have d. Okay, our third derivative is 12x squared. Again, here you apply the power rule. If you apply the power rule, you will have 24x. You can still find the fifth derivative, right? Because the derivative of this is 24. You can still find the sixth derivative. The derivative of 24 is the constant. The derivative of 24 is 0. Then after that, all the derivative will be 0 because the derivative of 0 is 0. Right. Do we have questions on the higher order derivative? Are we all together?
Hi, ma'am.
Yes.
Yes. Okay, I understand everything after the second derivative, but in the first derivative, why did we go to 1/5x?
Why did? Okay, remember this. Okay, our original function was 1/5x to the power 5, right? Okay,
Yes.
we have x to the power 5/5. This is the same thing as 1/5x to the power 5, right? C is equal to 1/5x to the power 5, right? Meaning we have the derivative. Okay, we need to apply a power rule here. And again, the derivative of a constant is 0. Right? So, okay, let me do it like this. I'll let this to be U1 and this to be U2, right? If this is the case, the product rule says C prime would be U prime 1 times U2 plus U1 U2 prime, right? Your U1 is 1/5. The derivative of the, okay, we have U1 as 1/5. The derivative of the constant is 0, right? And you have U2 as x to the power 5. The derivative of this would be 5x to the power 4 because you need to subtract 1. Right? And then the next step is to substitute all these here. If you substitute, we'll have C prime as our U prime, U1 prime is 0 times U2 x to the power 5, right? Plus our U1 is 1/5 times U prime 2. U prime 2 is 5x to the power 4, right? This gives you 0 because anything multiplied by 0 is 0, right? So this means you have 1/5 times 5x to the power 4. 1/5 times 5, the 5 and 5 will cancel out and you'd be left with x to the power 4. Right? Which is this.
Okay, thanks, ma'am. I understand now.
All right, thank you. Do we have any more questions? Okay, in your spare time, please try and work on this. Okay, we have C at X as okay, 2x to the power 4 plus 5/2 x cubed plus root x plus e to the power 3x plus ln x squared. Okay, please find x prime prime at derivative fourth derivative up to the fifth derivative. Okay, this is your function.
Ma'am, I'd just like to ask, is that first part multiplied with each other?
Pardon?
The first part of the function, is it multiplied with each other?
The first part's here.
Yes.
No, this is just negative.
All right, thank you.
Okay, next time on our last section, I will try and do the optimization of the function and then find the interval whereby the function is increasing or decreasing. And do one example. I'm not sure whether I'll be able to cover the application of differentiation, or I will ask the other lecturers to start from there. Yeah. Okay.